Okay, here's 4.4. It's called scatter plots and lines of fit. So first off, a scatter plot is going to be a graph that shows the relationship between two data sets. So here's an example where we have the number of absences of different students and also the test scores of numbers of students. So, you know, this particular student looks like they have 5 absences and they scored 40 on the test. Right, for example. Okay, so these are, it's just a bunch of different data points. So each one of those dots represents a different student. Okay. All right, in this example, like I said, it shows the relationship between absences and the score on the final exam. Okay, so here it says 2 students scored 100%. On the final, how many absences did they each have? So this is just reading the graph. So I'm looking at the test scores, and it's this one and this one, right? So one of the students, this student right here, had 0 absences. Okay, it looks like this one right here, it's a little hard to tell, but if you go down here, it's got to be an integer, so that looks like it'd probably be 1 absence there. So I'm going to say one of them had 0 absences, the other had 1 absence. Okay, and then it says one student has 13 absences. So I'm looking down at the absences, it goes all the way to 15 here. There's no one at 15, that's the closest, right? There's someone at 10 absences, and this is somewhere between 10 and 15. So let's assume that this is going to be exactly at 13. Okay, and then what I want to do is figure out what the score on the test was. So I'm going to trace this back to the y-axis there, and it looks like this would be the point 2013. And my x-coordinate is the test scores, right? This would be the x, and then this would be the y. So that means a test score of 20 with 13 absences. So the score on the test, 20%. Okay. All right. So data sets can have what's called a positive correlation, a negative correlation, or no correlation. Right. So I'm going to get those examples on screen at the bottom here. All right. So a positive correlation means that data points on a scatter plot appear to line up somewhat with a line with a positive slope. Okay, so that would mean it's going to be a line that looks like it's going uphill from left to right, would fit the data. So if you look at these 3 examples, this one seems to have a positive correlation because it looks like those kind of line up with a straight line that's going uphill. So that's the question it's asking. Do these appear to have positive, negative, or no correlation? So this one appears to have positive. And this is, it makes sense if you read it. It's men's shoe sizes and heights. So, you know, in general, the shorter people are going to have smaller shoe sizes and the taller people would have bigger shoe sizes. It's not an exact formula, but that's in general what's going to happen. So there's a positive correlation between shoe size and height. Okay. A negative correlation means that the data is going to fit a negative line, at least to some degree. So if you look at this first example here, that looks like a negative line is going to fit that to some degree. So this has a negative correlation, and that's it's the example that we were looking at the beginning with number of absences and test scores. Kind of makes sense. The students who are always there tend to do better on the test. Students who are absent a lot might do worse on the test in general. And of course there could be outliers. That's why it doesn't line up exactly on a straight line, but that's the general correlation. Okay, and sometimes you might see a scatter plot where there doesn't seem to be a correlation at all. So here we've got shoe size and IQ. Well, shoe size doesn't have anything to do with IQ. There's no correlation at all. So, you know, you get people with small shoes that have high IQs and low IQs, and the same thing with the large shoes. You could get a high or a low IQ or medium. There's no correlation there at all. So this would be an example of no correlation. It kind of just looks like random points. It doesn't look like a straight line would fit that very well at all. Okay. All right, on the next page, let's talk about a line of fit. So a line of fit is a line drawn on a scatter plot that is close to the data point. So we've got these points here. It looks like they have a negative correlation, and then this is going to be a line of fit. Okay. So if you are trying to draw a line of fit on a graph, what you want to do, make a scatter plot of the data. You're going to decide whether the data can be modeled by a line. If there's no correlation, then you can't really draw a line of fit because it's going to be just random points. But if you do see either a positive or a negative correlation, then you can draw a line. So you just kind of eyeball it. You draw a line. There should be about as many points above the line as below the line. And if you look at that example, I'm not going to count them up, but it looks generally like there's the same amount of points above and below. Okay. And then if you need an equation for that line, then you would choose 2 points on the line, any 2 points on the line to write the equation. Okay. So let's try this out with an example here. Okay. The data shows sales of a DVD for each week after release. We're going to make a scatter plot of the data and then also write an equation for the line of fit. Okay, so I'm just going to plot these points. So week 1 got $19 million. So 119 is right there, right? And I'm going to go through the rest of these. 215 be right here. 313, 411, and so forth. Okay, so now that I've got those graphed, it does look like it would fit, it has a negative correlation, right? So now I'm going to just sketch in my line, and I'm just kind of eyeballing this. I'm getting out a ruler because I want to have a straight line. Okay, something like that. That would be, and for this one, I can't go into the negative for weeks, right, for time, or so it's going to stop at the y-axis there. But there's my line of fit, okay? And yours might look a little different, but it'll be something very similar to this, okay? And so now writing the equation, what I want to do is pick 2 points that appear to be on that red line that I just drew. And it's helpful to use 2 points, if you can, choose 2 points that look like they're on the grid or very close to the grid. So there I'm seeing, okay, that looks like the point 118 that I just plotted on the graph. And then let's see, this one would be 314. So now I can write an equation using those 2 x-y pairs. If you can't find points that are exactly on the line, if it's very close to the line, that would work too. It just makes it easier if you use integer points like I did instead of decimals or fractions, okay? So I'm going to be writing the equation for this. So I'm going to need the slope. And the way I'm going to find the slope, since I have a graph in front of me, I'm just going to count. You could use the slope formula though, right? You'd subtract the y's in the numerator and the x's in the denominator. But I'm going to just think rise over run. So I'm thinking, how am I getting from that first point to the second one? Well, I'm going to go down 1, 2, 3, 4 units. And then I'm going to go to the right 2 units. So that's my rise and my run. So it's going to be -4 over 2, which equals -2. So my slope is -2. Okay. So now I'm going to use point slope form. You could use slope intercept form, then you still have to find the y-intercept, but I'm going to use point slope form here. So point slope form looks like this. I chose this because I'm ready to write this equation. I have a through point that I'm going to use for this, and I have the slope, which I just found. Okay. So my through point, I can choose either one of these ordered pairs. It doesn't matter. I think I'm going to use this top one. But you could plug in the 314 if you wanted. So I'm going to plug in 18 for y, and I'm going to plug in then -2 for my slope in this slot, and my x sub 1 would be 1. Okay. Now it doesn't actually say what form we want the line in, so we could just call it a day there. I'm going to rewrite this in slope intercept form, And so I need to, that's y equals mx plus b form. So I'm going to distribute first to get rid of the parentheses. Negative 2 times negative 1 would be positive 2, and then I'm going to add 18 to both sides. Okay. And now y is going to equal negative 2x plus 20. Okay, so there is my equation for my line of best fit. And you know, if you drew your line a little bit differently or chose two different points, you might get a slightly different equation, but it should be something that's very similar to this. And then what I could do, it doesn't ask me to do this here, but I could make a prediction, right? I've got these points, but I could see, well, what do I think the sales are going to be at 10 weeks, the 10th week, and I could just plug in 10 for x and then figure out what the sales would be. Okay. All right, that's it for this lesson, and I'll see you next time.